Hello everybody and good evening for Professor Chanyut. Before we start, let me introduce myself. My name is Asrawut Upakandi. So today we are gonna be present about our workpiece for the drawing project. So we got a 8 piece, or you can call it a jig fixtures. So the main duties for the jig fixture is for locking the piston parts. The piston parts is the conrod cap. You can see here is a conrod cap. The jig fixture is a locker for the conrod cap, and then after you lock the conrod cap, you can making a hole with the drill to the conrod cap right here. There is a hole right here, two sides. You can make a hole with the drill on the conrod cap with jig fixtures. Or you can see here there is a conrod cap. You put it down and the V block just block the conrod cap, so the conrod cap cannot moving away. And after you put the conrod cap lock with the V block, you can also lock it up with the U cycle here. Lock it so it can't move in any ways. So you can put the driller through the hole here, and then you can make a hole right here, two sides right here. And here is the face of the jig fixtures. Here, jig fixtures. Here is the diff lock. Diff lock is for locking the hole, so the hole is not moving to any way because there is a lock locking the hole. So the part that lock the diff lock is the nut right here. The nut right here. So it will be locking the hole so the diff lock cannot move it anyway. Here is the side of the jig fixtures. Here is the top. Here is the square nut. So the square nut is the locker of the V block. If you can see it, the black part or the black color of the nut, it probably a standard part. And here's the back of the jig fixtures. And here is when we disassembly, and here is all of the part that in the jig fixtures. You can see here is the diff lock, here is the U circles, here is the circle block, here is the top block, is the base block, is the vertical base, and it's the locker for locking the diff lock, and the main shaft, and the pin, the nut, and the workpiece. U block, V block right here. So yeah, here is all of the parts. So next we will talking about how we disassembly the workpiece. I will explain on SolidWorks or in the drawing. And here is our drawing. Here is the exploding drawing. As you can see here is the table. All of the part right here with the quantities, standard materials, and the part name. At first, we disassembly with the nut. We put all of the nut out. Start with the top block. We disassembly the nut right here, and the diff lock with the nut. We disassembly and we take the square nut off so we can put the top block out. And the next step, we put all of the nut at the back of the vertical base out. So if you put it down or put it off, you can put the circle block right here off with the pin. But if you put the circle out, you cannot drag it off, because you have to use the hammer and you have to push or smash for the pin out with the needle, small needle, for put it in the hole, and then you use the hammer to smash it down for the pin to come out. And after you put the square knot off, the V block will come out too, because the square knot is the controller of the V block. After you put the circle block off, you can get the long pin here. And then you can see here the square block. Square block is also have a pin right there at the back. You should also have to use the hammer and the small needle to put it off too. So after you put all of the part that I have mentioned out, it will remain the vertical block and the base block with their nut. So you have to use the helix. Use the helix to make the knot off at the base right here, and then you will get the base block and the vertical blocks. And then if you do it all of that I have mentioned, you can be completely disassemblies. Disassemblies, not die, sorry. So here all the tables right here, there is a description of our part and the standard part. The standard part that we use is the nut. Is all of the nut right here is 100% of the standard part, except of the main shaft and the square nut. So we make it by ourselves, not the standard part. And also the pin. The pin is also the standard part, because we can find in the website here. Yeah, here's the dowel pin. We can find the dowel pin right here, so it's the same type of the pins in the jig fixture, so we use the dowel pins in the website. And about the nuts that we use is 912 908230. 912 908 230. And here is the standard nut that we use here. See the product detail. Yeah, there is a standard part that we use in the website. So let's talking about when we assemble back. And I also have the video when we have to assemble back into the fully assembly jig fixtures right here. There is the videos. The way we assemble back is reverse from the disassemblies. So the reverse is we have to make the base and the vertical base to combine, and then lock it up with the nut. Yeah, lock it up with the nut, and then After we completely combining the vertical base and the base, we have to combine the circle block with the vertical block or vertical base. Here you have to put the circle block on the vertical block and then use the knot with the helix. Lock it up with the knot and then with a pin. After that, you have to put the square block on the side of the circle block and lock it up with the knot and pin too. After you have completely done with the front of the vertical block, and then you do the top one with the top base. So you completely put the div lock, put the knot, put the square knot before we combine the top block with the vertical block. After we put the top block on the vertical block, we have to use the knot to lock it down to side and use the helix to make it hard to move. And then the last thing is to put the main shaft and the U circle and the V block on the top. And here we are. All the parts is completely assembly. Our step for the making assembly drawing is to create every part before assembly. Before we made the part together, we have to make every part. So my duty is to make every part and then assembly and then make explode views. So my mistake or my problems is the size of every part and the standard part. After I build every part, I cannot be made or I cannot assembly it because the size is not the same. So in the programs, every size should be fit, not be. It can be less than, but it cannot be more than. If it's more than, the shaft cannot fitting in the hole. Cause of these mistakes, I have to rebuild every part and change the diameter, change the dimension, and change the position of the part so it can be assembling it.
Hello everyone, my name is Wedwasin Harutabiticho. Today I will present about the 2D drawing. The purpose of creating this 2D drawing is to make it easy for everyone to understand the preset and their site. Let's start with this one called vertical bed. Start with the top view. You can see only 2 holes with the thread holes, and I cut the section, and you can see here, but it not have like all information of the pieces. So I add this wheel. So I add back wheel to improve more information and complete the pictures. Now let's talk about this place. Number 2, which color the square block. This plate acts as the foundation for deepening holes. We have a total of 2 of this block, and this is a front wheel and left wheel, and top wheel we add 3 wheel, and we cut section AA at left wheel to get this, and we cut section BB as front wheel to get this. At the top wheel we have a flatnet which 0.02. Let's move on to piece number 3, named the circle block. This place is another bit used for deepening hole. You can see here, this is a bottom wheel. We add here, and we add the front wheel. We cut section AA to get this section here. We cut section BB to get this, and then the top wheel we add the pollution which 0.02 and the data MAE. Now let's talk about the piece called the piece number 4, called the U block. This piece is designed to hold and lock the workpiece in place during hole deepening to prevent any movement. Let's see. Here we have a top wheel and the front wheel. At front wheel we have cylindricity which 0.6. Let's continue with piece number 5, named the top block. This piece serves as the top support base. The issue with this piece is that the measure distance doesn't seem really stable, but it's okay. You can see here, this is the top view we add, and we cut section AA here to here. We got this, and we cut section BB. We got this. Now let's move on to the piece number 6, called the base block. This place is continue to serve as the bottom support base. As you can see here, this is the top wheel here, and we cut section at top wheel to get this section, and we got a fat net which 0.03 here. Yeah, that's all. Now let's move on to the V block. Is piece number 7. This place is located on top of the workplace to be deep. Its purpose is to place and lock the workpiece in place during hole deepening to prevent the movement. As you can see here is a top wheel, and we cut section AA to get here. You can see inside it. Now let's move on to the piece number 8, called the deep block. This place serve as a block for workpiece to be dipped. Additionally, this place is hardened to prevent any damage during dipping. As you can see here is a right wheel, and we add a front wheel and a left wheel too. We can section at right wheel, section AA. This place is hard to understand, so I think we should add here to someone who need to make up this, please. Yeah. Let's move on to the piece number 9, named the square nut. This piece is a nut used together with the top block and V block to secure the workpiece during dipping and prevent it from moving. This is another. We add a right wheel and front wheel. Now on to the final place, named the main shaft. This is a bolt used in conjunction with the U block, circle block, and vertical base. It secures the U block and the workpiece being dipped to prevent movement. As you can see, here is the right wheel and the front wheel, and we cut section section AA in front wheel to get this. The all surface is N7. Is all. Thank you.
My name is Kittipop Aryamongoskun. Today I will explain drawing in paper of our group. Let's go to the first part. The first part is a base. The base have a surface roundness is N7, and the size of his base is 100 times 80. 100 times 80. And it have a section here. Why I have section? The section show the size hole here. The size hole is M5 times 0.8, and it have a GDNT is fatness 0.03, and this part is scale is 1:1. Okay. The second part is vertical base. The vertical base is the surface roundness is N7, and the size of vertical base is 100 times 80. And I have a section A here to see every hole in this part. This part have a hole at the top and the bottom. The depth of the top is 20.5, and the depth of hole at the bottom have 9.7, and the biggest hole nut, the size is M14, and this hole, and this hole, it has a same size is M6, and the smallest hole this hole and this hole. The size is diameter 3h7. Okay, let's go to the next part. The third part is the top box. The top box have a surface roughness is N7. The size of this part is 34 times 100. Okay, this part have a two section. Let's go to the first section. First section is section AA. As you see, at the section AA it have two hole nuts. The size is M6, and the head size of this hole nut is diameter 11h6. Okay, next is the section B. In the section B, it have a hole size, but this hole, and this hole, it have the same size, is M10, and this hole and this hole, it has the same size too. That hole size is 18, and this scale of this part is 1. Okay, next part is a circle box. The circle box have a surface roughness is N7. The size of the circle box is they have diameter 40, and the hole at the middle one, the size is 12, has 7 and 6. Okay, and this little hole and this hole is the same size, is diameter 3, and this hole and this hole is a nut hole. The size of nut hole is M5 times 0.8, and this part I have two section too. Let's go to the section AA first. In the section AA, here you have to see the hole little one here. The depth is 7, and section BB, here the depth of the hole nut is 16, and the scale of this part is 1. Okay, next part is a square box. Square box have a surface roughness is N7. The size of square box is 15 times 10, and at the front it have a hole that break through at the front to the back. The side hole is diameter 6, has 7 and 6 here, and you can see here. And the side view, we have two holes, but these two holes didn't break through to the middle hole. The size of this hole is M5 times 0.8, and this little one hole is diameter 3. And in this picture I have two sections. Let's go to the first section first. Section AA here, and that you see, this hole didn't break through at the middle hole, and this hole have a depth is 4, and the section B is here. But you can see that the middle hole here can break through at the front to the back. And the scale of this picture is 2:1. Next part is U-box. U-box have a surface roughness N7. The size of U-box is diameter 50, and the side of the middle is diameter 12, and the length that at the top to the middle is 30.7, and it have a 10 roundness. Okay, next part is U-box. U-box have a surface roundness is N7, and the size of the U-box is 50, and the size of the circle curve here is diameter 12, and the length at the top of the circle to the middle is 30.7, and this U-box have a thickness is 30, and GNT is surrender 0.6, and the scale is 1:1. Next is V-box. V-box have a surface roundness N7. The V-box have two holes. The biggest hole, the size is 7, and the small hole, the size is 3/6, and this range is 20, and this range is 10. You can see they have a V shape here, and the hole is not made to. It have a small hole here to separate it, and the scale of this part is 4:1. Okay. Next is a square nut. The surface roundness is N7. The size of the square nut is here, then here is 42.6, and at the head of the square is a square shape. The size is 7.46 and 9.4, and this one, the thickness is 2, and the shape of it is a circle. The size is 12 here, and the size of this nut is M8 here, M8, and this nut have a mark here to here is 25, and this part scale is 2:1. Okay, let's go to the next part. The next part is a main shaft. The main shaft have a surface roundness is N7. The length of all here is 58.3, and the head of shaft is 20.4, and the shaft, the side shaft is M12 times 1.75, and it have a chamfer here, it's 0.4, and I have a section here to show that it have a little hole at the head of the shaft. The depth of the shaft, the depth of this hole is 4.2, and the size of this hole is 3.1 diameter, and the scale is 1:1 here. Okay, the last part is diff lock. The surface roundness is N7. As you can see, this view is from the bottom. We have cut it here, and we cut it in radius 6.5, and the biggest one, the circle, the size is 21.9, and the middle circle here is diameter 12, and this one it has chamfer 0. Radius 0.5, and let's go to the top view of this part. As you can see, here and here in the same part, but it have to cut it a little here. The radius is 6.5 and the thickness that we have cut it is 5. You can see this side in the section view, and in the section view you can see that this block have a back tool at the top to the bottom. The size of this hole is here 6.7, and the length of this part is 22 here 22, and the scale is 2:1. Okay, that's all. Thank you for watching.